This video is sponsored by Unity. In this video, we're going to look at 3 ways of shooting projectiles and 3 ways of doing hit detection in Unity. All methods are valid, each with their pros and cons, and which one you choose depends on what game you're making. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Alright, so this is what we want to make. Over here is my player character, and in here we have some nice targets. And now if I click, yep, I'm firing a projectile. Now this is the first projectile type. It spawns a game object and moves the transform. Then I can press a button in order to swap to the next projectile type. And visually it looks exactly the same, but it's working quite differently. This one is working by using the physics system. And now these 2 projectile types also have 2 separate hit detection methods. Now the first one is using a distance check, and there you go, it can hit all the targets. And the second one is using a physics collider. And again, visually they both look exactly the same. So they both behave similarly and achieve the same result. So these are the 2 normal projectile types. And now for the last type, which is not literally a projectile, but rather it simulates a projectile. This is the raycast method. So I can shoot, and yep, there's the supposed projectile. This one is using a raycast, so it's an instant sort of projectile. It gets fired towards a direction and does a raycast to test if it hits something or not. So here are the 3 methods of shooting projectiles that we're going to look at. One using a transform to move our bullet, one using physics, and one using a raycast. We're also going to try the 3 hit detection methods, one using a distance check, one using colliders, and one using raycast. As you're building your games, you're going to need some assets and tools. Check out the Grow Your Skills Mega Bundle sale happening right now on the Unity Asset Store. Get over $1,000 worth of assets for up to 90% off. So this is an excellent chance to get some assets at a great discount. Get some awesome assets to build up your levels, some characters to play around with, and lots of awesome effects. Get some tools to improve your workflow, like In Control for setting up multiple controllers and Playmaker for visual scripting. Also included in the Mega Bundle is 1 year of Unity Learn Premium. This is Unity's official online learning platform, and it contains lots of completed projects, courses, and tutorials, all officially certified by Unity. Unity Learn Premium has over 500 tutorials in structured learning paths at every level to help you upskill and reach your goals. So if you've been meaning to look at Unity Learn Premium, then this is your chance. For the normal price, you can get it through the bundle alongside tons of awesome assets and tools. The link in the description is also an affiliate link, so if you pick up anything through there, you'll also be helping out the channel. So check out the Mega Bundle sale, get some awesome assets and tools, and check out Unity Learn Premium. Thank you to Unity, and thank you to these awesome supporters for making this video possible. Go to patreon.com/UnityCodeMonkey to get some perks and help keep the videos free for everyone. Alright, so this is our goal. Let's get to it. Okay, so here we are in our starting scene. I have my player character that I can move around. I covered a basic character controller in a previous video, and I can look around and shoot, and I also covered how to aim towards the mouse in another video, so check the links in the description to learn more. Now as you see, when I click it plays the shooting animation, but it doesn't actually fire anything. Alright, so let's begin by creating our bullet. Over here in the project files I already have a simple bullet sprite, so just drag it onto the scene, and yep, there's the sprite. Now let's set this up. So let's make an empty game object to hold our bullet. And inside let's drag our sprite, call it our sprite. Just making a parent game object so we can later expand upon our bullet. And also let's rotate the sprite to point it to the right, which is Unity's 0 angle. So in here just put -90 and yep, exactly like that. Alright, so here's our simple bullet game object. Now let's just drag it onto the prefabs folder in order to create a prefab. Let's rename it to PF bullet. Alright, so we have our bullet prefab. Now let's instantiate it when we shoot. And now over here in the scene, I have a game object for my player. It has a bunch of scripts in order to handle the animation, movement, and so on. And then here we have the simple shoot projectile script. Let's open this up. And it's in here that we're going to handle our shooting. All of our code is set up in a very clean way with all the systems nicely separated. So here we're handling the shooting by listening to the onShoot event that is fired by a base class. So this is how we keep everything nicely separated. If you want to learn more about the events, then check the video linked in the description where I cover them in detail. Now here we can simply spawn our bullet. So for that, let's first add a nice field for our PF bullet prefab. And then in here, we can simply call instantiate our bullet prefab. Now we need the position. And for the position over here, the event comes with a onShoot event args. And in there, it contains the gun endpoint position as well as the shoot position. So let's spawn the bullet right on the gun endpoint position. And for the rotation, let's pass in quaternion identity. All right, so just like this, it should be spawning the bullet. So let's just go into the editor. And in here, we just drag our bullet prefab reference and try the game. Okay, here we are and shoot. And yep, there you go. There's the bullet spawned exactly where it should. All right, so we have our nice bullet being instantiated. Now that we have the bullet being instantiated, let's actually move it. So for that, let's make a script to handle our bullet. So a new C# script, call it just bullet. Let's drag it onto our prefab. So just there and drag it. Okay. Okay, so now in here, in order to move our bullet, we need to know which direction we should move towards. So let's make a function in order to receive that direction. Let's make it public void, call it our setup function, and we're going to receive a vector3 for the shoot direction. And now we can go back into our player script, and in here we instantiate the bullet. Okay, let's grab the instantiated transform, so our bullet transform. And then we do get component to get our bullet component. And we call our setup function. And now in here we need to pass in the shoot direction. So let's calculate that. In here, vector3 for the shoot direction. And again, over here on the event args, we already have the two positions. So the shoot position, which is the target position. So let's do that minus the gun endpoint position. And let's make sure that we normalize our vector. All right, so we have the shoot direction being calculated and we just pass it on to our bullet. So now the bullet here receives the shoot direction. Now we just need to store it. And then we make our normal update. And on update, let's simply move the transform.position towards the shoot direction multiplied by time.delta time. And let's also multiply it by a certain move speed. And just like that, very simple. So we have the player which calculates the shoot direction, then passes that shoot direction onto the bullet script, and then the bullet script stores that direction and simply moves towards it. So if we test, so here we are moving around and shoot, and yep, there you go, there goes the bullet going in that direction. So shooting there, and yep, goes straight towards the mouse. All right, great. So here we have our basic bullet working. However, you can already see that we have two issues. Now, the first one is that the bullet isn't rotated. So if I shoot upwards, yep, there you go. You can see that the sprite is still pointing to the right. And secondly, the other issue is that the bullet lives forever. So if we pause, over here, you can see that we have all of these bullets being instantiated and they all still exist. So this one, for example, is all the way over there. Obviously, we don't want our bullets to live forever. So let's solve both those issues. Now, first for the rotation, it's actually very simple. When we do our setup, we receive the shoot direction vector. So we go into our transform to modify our Euler angles. And in this case, we're working in 2D. So we're going to leave the X and Y at 0. And now for the Z, we need to convert this into an Euler angle. And for that, I can use one function from the utilities in order to convert a vector into an angle. As always, you can download the CodeMonkey utilities for free from unitycodemonkey.com. And here is the function in case you want to build it yourself. All right, so just like this, we should have fixed the rotation. And now for the bullet cleanup, there are several ways that we can do this. We could keep track of the distance the bullet has moved and destroy it after a certain distance, or we can destroy it based on time. Using the time approach is very simple. Here on setup, we can just use the destroy function, which is part of mono behavior. And we're going to destroy this game object. And this one takes a second parameter, which is a time. So in here, let's say after 5 seconds. So after 5 seconds, this game object will be destroyed. Okay, that should do it. Let's test. Okay, here we are. And first, let's see the rotation. So if I point upwards, yep, there you go. It's now being rotated perfectly wherever I aim. Great. And let's pause. And over here, we can see all of our bullets, and they should all be destroyed after 5 seconds. So I shoot them, they get spawned, and after 5 seconds, they should become clean up. And yep, there you go. They start being destroyed. All right, awesome. Okay, so we can now spawn to shoot our bullets, and after a while, they get destroyed. However, right now, they're not hitting anything. So if I shoot at the targets, yep, nothing happens. So here now we have two methods of detecting hits. We can decide to use the physics system or not. Let's first do it without the physics system. So here in the editor there are the various target game objects. They essentially just have two sprites, and then over here they have the target script. Let's inspect this. Here it is. It's a pretty small, simple script. Now it's already set up in an interesting way. We have a static list of all of our targets, and on awake every target gets added onto the list. So with this list, we're going to have all of our targets. And then up here, we also have a nice static function. It takes in a position and a certain max range and returns the closest target to that position within that max range. So it cycles through all the targets in the target list, calculates the distance, and returns the closest. So this is the same method that I use in the melee combat system that I made previously. And now with this simple function, we can use it to test for hits. So let's go back into our bullet script. And in here on our update, all we're going to do is call that function. So let's go into the target in order to get the closest. Now for the position, let's pass in transform position. And for the max range, let's define a certain hit detection. And now this function returns a target. So first we test if our target is not null. So if we do have a target, then let's just call the target.damage function. And once we do, let's also destroy this game object. Alright, so that should do it. We test for the closest target to this bullet position within a certain radius. And if there is something, then we're going to damage the target and destroy the bullet. Let's test. Okay, so here we are. We can still move, we can still shoot normally. Alright, and now if we shoot at the target, and if there you go, we correctly hit the target. So our bullet is testing the position, looking for the closest target within a certain radius, and if it finds something, then we have our hit. Awesome! So we can now fire bullets and have them hit our targets. And here you can see the first method for shooting projectiles by using a transform in order to move them, and the first method of hit detection by cycling through our targets and doing a distance check. Now this method of hit detection has some pros and cons. The main pro is it does not require the physics system at all, so it works with a simple vector 3 position. There's no need for any colliders or anything of the sort. However, the one downside is we're testing the distance against every single target. If you have a small amount of targets, then this isn't really an issue, but if you have a lot, then it can quite quickly become very expensive. So let's look at the second method for hit detection by using the physics system. So first here in the editor, let's add a box collider onto our target, and let's edit it to put it right on top of the target. Okay, just like that, there's our collider. Now we also need to add on our projectile. So let's open up our bullet, and in here also add another box collider. And again, set the size. Yep, just like that. And now if you've seen the video where I covered simple collisions, then you know that just like this, it won't actually work. In order for the collision to work, we need to have at least one of the objects with a rigid body. So let's add it over here on our bullet. We add a rigid body 2D. And now since we're moving the transform directly, we need to make sure that this rigid body is set to kinematic. Then to make it move smoothly, let's interpolate. And in order to not teleport between targets, let's make sure that the collision is continuous. And here, let's also make sure that our bullet is a trigger. Alright, so here we have both objects set up. We have the bullet with a box collider and a rigid body. And then we have our target just with a box collider. So now let's go into our bullet script. And in here, the way that we handle collisions is actually very simple. All we need to do is add the function private void on trigger enter 2D. We made the bullet a trigger, that's why we're using the trigger. And using enter means that it will only be called once when the bullet enters into another collider, and we're working in 2D. Alright, so this will be called when there's a collision in the physics system. Now all we need to do is check if the collider that we hit was a valid hit. So let's test if our collider.getComponent of type target, if it is not null, then we have hit a target. Alright, so if our collider does have a target component, then we hit a target, so we call target damage and we destroy the bullet. So that's it, very simple. Now we can comment out the previous method for hit detection and just test this out. Okay, so here we are and still shooting normally. Alright, so far so good. Now let's shoot at the target. And yep, there you go, the collider hits and we have our target hit. So we can shoot at all of our targets and all of our bullets are colliding exactly as intended. Awesome! So here we saw the second method of hit detection. we're using the physics system in order to test when a collision occurs. Then we test if we collided with a valid target, and if so, we do our hit logic. Now, the benefit of this approach is we don't have to test for collisions on every single update against every single target. When it happens, the physics system will let us know. So when dealing with projectiles, this is probably the better approach for hit detection. Now let's look at the second method for handling the projectiles. For that, let's go and duplicate our prefab, call this our bullet physics. And now since we already set up everything to handle physics collisions, then everything is almost set up. The main difference is down here, instead of kinematic, it will be a dynamic rigid body. So we make it dynamic. Let's make sure the angular drag is set to 0, as well as the gravity also set to 0. Alright, so that's our setup. Not much different than the previous method. Now let's make our script. So let's make a new C# script, call it our bullet physics. And now in here, let's also make a setup function where we receive the direction. So a public void setup. We receive a vector3 for our shoot direction. And now when we receive it, on our other method, we were storing the shoot direction, then using it on update in order to move our transform. However, in here, we're going to use the physics system directly. So instead, let's get component of our rigid body 2D. And then we use our rigid body in order to call add force. We're going to add a force towards our shoot direction and make sure that it's an impulse. And finally, since shoot direction is normalized, let's also add a certain move speed. Alright, so just like this, our object should be moving in the world. Now let's just spawn this type of bullet. So let's go into our player and let's duplicate to add a field for the bullet physics transform. And here we're going to use the second method. Alright, so just like this. So it's essentially pretty much the same code as previously, just with a different component and a different prefab. Okay, so all this should work. Let's test. Okay, so here we are and shoot. And yep, there you go. The bullet is still being spawned and flying towards the target. So it's behaving pretty much exactly the same as the other bullet, except this one is being controlled by the physics system. Now we forgot to solve the issue with the rotation, so let's solve that. And then we also need to solve the hit detection. So let's do those. So we can pretty much copy the same code as in the bullet. So for example, over here we have the Euler angles and the cleanup after a while. So we can pretty much copy the exact same thing. And for the collision, also pretty much the exact same thing. Alright, so that's it. Now this should be working. Let's test. Okay, so here we are and shoot. And yep, there goes the bullet. Shoot to the other side. And yep, the rotation is all correct. Now let's shoot at a target. And yep, there you go. We have our hit detection working. So we can shoot the bullets, hit the targets. And if not, then they keep going and they get cleaned up afterwards. Alright, so everything is working correctly. Awesome. So just like this, we have our second method of handling projectiles. This one is using the physics system in order to handle its movement. And we're also using the second hit detection method, which is also based on physics. So we have our bullet correctly working exactly as intended. Alright, so we looked at two methods of shooting projectiles and two methods of hit detection. First, shooting by moving the projectile with the transform, and secondly, by using the physics system in order to move it. And for the hit detection, we tested the distance against all objects, and we also used the physics system in order to handle our collisions. Now let's check out the third method for shooting a projectile and the third method of hit detection. Now this one isn't technically a projectile, but rather a way that you can simulate a projectile in your game. I'm talking about having an instant projectile. So as it's fired, it instantly either hits or misses. For that, let's make our script. So a new C# script. We're going to call it our bullet raycast. And now here, our supposed bullet is just going to be an instant, so we're not really going to have any object at all. So since we're not going to instantiate this class as an object, then let's make it a static class and get rid of mono behavior. Alright. Now let's make a shoot function. So a public static, let's return void and call it shoot. We're going to shoot, take a vector3 for the shoot position and a vector3 for the shoot direction. So we're going to shoot from this position towards this direction. Now in here we do a simple raycast. So go into the physics 2D in order to do a raycast, start on our shoot position and go towards the shoot direction. Now this will return a raycast hit 2D. And we can test if we hit something by checking if our raycast hit 2D.collider. If it is not null, then we have a hit. So if we hit something, let's test if it's our target. So you try to get the component of target on the hit collider. And if we have it, then we have hit a target. So let's cause some damage. Alright, so that's pretty much it for making a simple raycast. Now back in our player. Here, instead of using this other method, let's use our raycast method. So we go into the bullet raycast. In order to call the shoot function, pass in the shoot position and our shoot direction. Alright, so that's it. Very simple. Let's test. Okay, so here we are in shoot, and right now there's no visual, so you can't really see anything. But if we shoot towards the target, yep, there you go, we can indeed cause some damage. So we hit target, shoot down, and shoot down. And yep, just like that. So our raycast hit is working. Now for the visual, we can use a nice bullet trace visual that I made in a previous video quite a long time ago. Check the link in the description if you want to learn how it works. The way I set that up is very simple. I just use the weapon tracer class in order to create a weapon tracer from this gun endpoint position towards the target position. So let's say the mouse position. Let's see. Okay, here we are in shoot, and yep, now we have a nice round tracer visual. So we can now shoot all of our targets, and yep, we can now see them. Again, I covered this in a previous video, so check it out to see how it works. And just like this, we have our third method fully working. Instead of having a moving object, what we have is an instant either hit or miss. So depending on what game you're making, this might be the better approach compared to a moving projectile. Alright, so here is our final scene. Right now I can click and yep, I'm shooting projectiles. This is the first type that is firing a moving projectile by moving the transform. It's also using the first method of hit detection by checking the distance against all targets. And now by pressing a button, I am now shooting the second type of projectile. Now visually they are exactly the same, but functionally quite different. This one is using physics in order to move the bullet, and it's also using physics in order to handle the hit detection. And I'll finally click another button in order to use the third method. So now this one isn't really a moving projectile, but rather an instant shot. It's done using a raycast, and it checks instantly whether it hits something or not. So just like this, over here you have 3 methods of shooting projectiles that you can use in your game. Now go ahead and pick the one that best makes sense for your game design. Check out the Grow Your Skills Mega Bundle sale happening right now on the Unity Asset Store. Get over $1,000 worth of assets for up to 90% off. So this is an excellent chance to get some assets at a great discount. Thank you to Unity and thank you to these awesome supporters for making this video possible. Go to patreon.com/UnityCodeMonkey to get some perks and help keep the videos free for everyone. As always, you can download the project files and utilities from UnityCodeMonkey.com. Subscribe to the channel for more Unity tutorials, post any questions you have in the comments, and I'll see you next time.